For 1.1, we're looking at calculations, and this can consist of a number of different topics involving listing strategies and also priority of operations, as well as using your calculator. So let's get started. So for this first question here, we are being asked to look at a menu that's got 5 different sandwich fillings: beef, cheese, egg, ham and tuna, and 3 different cold drinks: lemonade, orange juice and water. Each of the sandwiches have been given a letter as well as the drinks. Part A asks us to list the combinations of sandwich fillings and cold drinks. Well, the best way to do this is to approach it methodically and do it in an order where you know that you aren't going to miss a combination. So let's start off by listing all the beef sandwiches with their assigned drinks. So we have beef and lemonade, beef and orange juice, and beef and water. Okay, there are no other possible combinations involving a beef sandwich. We can then follow this pattern with a cheese sandwich. So we go cheese and lemonade, cheese and orange juice, cheese and water. We follow this pattern for the other 3 sandwiches. And there we have it. All of the combinations are listed there. And because we did it in a methodical way, we can be sure that there are no other ones missing. And then when we look at part B, how many different combinations are there? We simply just count how many we've got. So we've got 1, 2, 3 down and 1, 2, 3, 4, 5 along. So it becomes 3 times 5, and that is 15. For the next question, we're going to re-examine the priority of operations. Namely, they are brackets, indices, which can consist of powers and square roots and various other things, division and multiplication, and then addition and subtraction. Note that division and multiplication are on the same level, as are addition and subtraction. So this question here asks us to insert brackets to make each calculation correct. So we start off, we've got 2 plus 3 times 5 equals 25. Well, clearly that doesn't equal 25. So we think, right, okay, so we're going to multiply by 5 and think, right, what multiplied by 5 would give me 25? That would be 5. So how do I make 5 out of these? Well, if I just leave it as it is, the problem is I would have to do 3 times 5 first. So by inserting the brackets there, that will then give us 2 plus 3, which is 5, and then times by 5, that gives you 25. The next one, we've got 2 squared minus 3 plus 1 equals 0. So again, 2 squared is 4. If I was to subtract 3 from 4 and then add 1, what's going to happen? Well, 2 squared being 4, take away 3 plus 1, does that equal 0? 4 take away 3 is 1, add 1 would give me 2. So that would be no good. So therefore we've got to think we need some brackets around here to ensure that we are subtracting 4 from 4. So if I was to insert the brackets here, we would now have 2 squared take away 3 plus 1, which would equal 0. The final one, we have 10 divided by 2 plus 3 equals 2. Well, 10 divided by 2 is 5. If I added 3 to that, I'd get 8. So we can think, right, 10 divided by something would give me 2. So if I insert the brackets here, I would then have 10 divided by 5, and then, of course, that does equal 2. Okay, so before we go on to the next example, we need to have a little look at the key point that involves the word inverse. So any particular function, and here we have a function machine over here, it contains a rule. Okay, the function here would be add 2. So if I started with 7, if I applied the function add 2, I would get 9. Now this word inverse means quite simply reversing the effect of the original function. So the inverse of this function here would be minus 2. So if you were asked to do the inverse calculation, you are essentially being asked to reverse the original calculation. And that helps us with this example here. So it says write a calculation to check each of these. And the first one, we have 345 add 728 equals 1073. So we can apply the idea of the inverse function. So currently I have 345 add 728 equals 1073. So if I apply an inverse calculation, I can start with 1073 and then I can subtract 728 and check to see, does that give me 345? So by quickly doing this calculation here, of course I would get 5 there, I'd get 4 here, and then 10 take away 7 is 3. So I get 345. So we would write 1073 take away 728 does equal 345. The same works with multiplication. I've currently got 347 times 14 equals 4,858. So if we apply the inverse, we start with 4,858 and we divide by 14 to see if that gives us 347. So to check this, we're going to do a little bit of division. So 14 goes into 4, 0. So now we have 14 into 48, which goes 3 times, with a remainder of 6. 14's into 65, goes 4 times, remainder 9. And then finally 98 divided by 14 is 7. So therefore, we can say (4,858) divided by 14 is 347. And for the final one, we've got 476 divided by 28 equals 17. So again, I can apply an inverse operation, and I can do 28 multiplied by 17. 8 times 7 is 56, 2 times 7 is 14, add the 5, 19, and then we have 8 times 1, which is 8, 2 times 1, which is 2, add them together, 6, and then 7, 476. So our answer, 28 times 17 is 476. For our next example, we've been given a word problem. So we have Abby is twice as old as Ben. Ben is 3 years older than Carl, and Carl is 16 years old. How old is Abby? Well, we can apply the idea of an inverse process by starting off with Carl. We know from the question, Carl is 16. What does it say about Ben in relation to Carl? It says Ben is 3 years older than Carl. So we can say Ben is 3, add 16. That's 19. And then we go to the next step in reverse and says Abby is twice as old as Ben. So Abby, take Ben's age, which is 19, multiply that by 2, and we have 38. The final example involves us looking at square roots, cube roots and squares. A square root is the inverse of finding the square. So something squared, the inverse is square root. Likewise, a cube root is the inverse of a cube. And there are two buttons on a calculator and two functions on a calculator that allow you to find square roots and cube roots. So this question says complete these calculations and check your answers using an inverse operation. The first one is 18 squared. So you go to your calculator and we type in 18 and we look for the button that says squared, and it's this one here. And you get 324. Now it asks us to check the answer using an inverse operation. So the inverse operation would be the square root of 324. So we go to our calculator, clear our screen, and we look for the square root button. Our square root button is here, and we type in 324, and we get 18. Next one, it asks us for 15 cubed. So a slightly different button here. So clear your screen, type 15, and then you need this button here, which allows you to raise that number to any power. And you see you've got a little box, you can enter your power in. We put 3, and you get 3,375. And again, to check that answer using an inverse operation, we would do the cube root of the answer we just got. So let's look for that on the calculator. Now, can you see in blue here, we've got what looks like a square root button, but it's got a little box next to it. So let's see what it does. So to get that, you press Shift and the square root button. And can you see now, this allows you to do any root. So we want a cube root, so we type 3 in there, press the right arrow, we put in 3,375, check our answer, and we do get 15. Final question, we want to do the cube root of 2,744. So again, go to your calculator. As we did before, press Shift and this button. Type a 3 to make it a cube root. Press the right button. Type in the number we want the cube root of. And we get an answer of 14. And again, inverse operation would actually be 14 cubed. Let's go back to our calculator and check that we do get the answer we want. And we do get 2,744. And there you have the first video on 1.1, which was calculations.